Hastings River Flood Study Extension Project was commissioned by Port Macquarie Hastings Council following the devastating March 2021 flood event. The 2021 event saw heavy rainfall across the catchment, with many gauges recording totals of over 100 millimetres across 4 consecutive days. Comboyne in the hills south of Port Macquarie had 3 consecutive days with totals of over 200 millimetres. The upper Rowlands Plains in the Wilson River catchment recorded rainfall with a recurrence interval estimated of between 1 in 1,000 to 1 in 2,000 years. The significant rainfall led to widespread flooding throughout the catchment. This led to major flooding along the upper Hastings River, Papenbarra and Wilson Rivers, and Mortons and Brill Creeks, to name a few. It was clear from the widespread damage and the impacted population that additional flood information was required to supplement what had previously been derived through prior flood studies. In response, the Hastings River Flood Study Extension Project was funded by Council, and Worley Consulting were engaged to prepare the study. Major components of the study include the extension and updates to the hydrologic and hydraulic modelling tools for the catchment, calibration of the models to recorded data for the February 2013 and March 2021 events. This is an important step to ensure the models can reliably replicate observed flood behaviour. Preparation of updated hydrology for the catchment based on the latest guideline documents and procedures. This involved the selection of new rainfall patterns for design flood events that in turn resulted in revised inflows that are input into the hydraulic models. And lastly, use of the hydraulic flood models to predict flood behaviour for a range of design flood events. This generates important flood information that includes flood levels and extents, depths and velocity mapping, and information on flood hazards and hydraulic categories, which includes the floodway corridor. As you may be aware, a flood model had been developed for the lower Hastings River as part of the 2006 Hastings River Flood Study. The extent of this model is shown in red. Although the model had been updated several times between 2006 and 2020, its spatial extent had not increased. As part of this study, the RMA2 flood model was extended along the Hastings River to beyond Kindy Bridge, along the Wilson River beyond Avenel, and along the Maria River to Connection Creek. The footprint of the extended RMA2 model is shown in blue. A two-dimensional two-flow model was also developed to cover the major tributaries that drain to the Hastings and Wilson Rivers. As shown by the yellow model footprint, this included the Papenbarra River, Mortons Creek, Brill Creek, and the upper reaches of the Wilson River. Combined, the RMA2 and two-flow models could be used to generate flood information for a much larger portion of the Hastings River catchment. Calibration is the process of reviewing the parameters and setup of a model to ensure it can achieve a good fit to recorded data. For the Hastings River hydrologic model, this involved the input of recorded rainfall data from the 2013 and 2021 events to see if the model could reproduce flow hydrographs that match those recorded at various gauges. The success of a model calibration can often be influenced by the quality of the input data available. This was a factor in the calibration of the Hastings River hydrologic model due to a lack of daily red and continuous rainfall gauges that are spread to cover a wide extent of the catchment. The issues associated with limited rainfall data were compounded by the high spatial variability of the event, which recorded large differences in rainfall totals and patterns throughout the catchment. Calibration of the hydraulic flood models, that is the RMA2 and two-flow models, involved the comparison of predicted flood levels to recorded flood heights at 14 stream level gauges and over 40 surveyed high water marks. The RMA2 model was found to predict flood levels for the 2021 event that were on average 0.12 metres lower than the recorded high water marks. As shown in Table 5-2 of the report, the average differences were skewed by challenges calibrating to high water marks around Telegraph Point. The two-flow model was able to predict flood levels for the 2021 event that were on average 0.28 metres lower than the recorded high water marks. Calibration of the two-flow model was challenging due to the steep floodwater gradient along the minor tributaries and creeks, and higher uncertainty in flows due to the lack of rainfall data. One of the major findings from the calibration exercise was that the RMA2 flood model was underpredicting flood levels in areas downstream of Hibbard, which includes North Shore and Port Macquarie. This led to the adjustment of model parameters and a review of riverbed elevations near the river outlet. Another major component of the study was preparation of updated catchment hydrology to align with the latest guidelines, which includes Australian Rainfall and Runoff 2019, which replaced the previous version that was adopted in 1987. This was a major change for the catchment, with all modelling prior to this study having been based on the 1987 version. This change led to the input of new rainfall data to define design events, which includes updated rainfall intensities and rainfall temporal patterns. Critical durations and temporal patterns were selected for design events based on the review of flow rates predicted at 35 locations throughout the catchment. It was determined that two storm durations, the 18 and 48-hour durations, were required for each design event, with the shorter 18-hour storm producing worst-case conditions in the upper catchment and the longer 48-hour storm producing worst-case conditions in the lower catchment due to higher flow volumes. The final design flows were validated against flood frequency analysis to give confidence in the flow magnitudes that are to be adopted for design flood simulations. This graph shows an example of this comparison for the Hastings River at Kindy Bridge gauge. It shows that the flows predicted as part of this study resulted in a better fit compared to the previous hydrologic modelling that this study is to replace. A probable maximum precipitation event, which is abbreviated as PMP, was also derived for this study. The PMP event is to replace the currently adopted extreme flood event, which was normally derived to be 3 times the magnitude of flow that is predicted for a 1% annual exceedance probability event, which is an event with an estimated recurrence interval of once every 100 years. The PMP event was derived based on application of the generalized tropical storm method. A 24-hour storm duration was identified to be critical for the catchment and the PMP. As shown in the graphs, the PMP event was found to produce higher flows than the adopted extreme event by roughly 60% along the Hastings River and 35% along the Wilsons River. This showed that modelling that had been completed to date based on an extreme event had been underpredicting maximum flood levels for the catchment. The RMA2 and 2-flow models were used to simulate the design events shown, ranging from a 5% annual exceedance probability event, which has an estimated frequency of occurrence of once every 20 years, to the probable maximum flood, with a frequency estimated to be around 1 in 100,000. The wide range of events gives Council and other agencies, such as the New South Wales SES, an extensive data set upon which to make informed decisions for the catchment and to plan for future flood events. As an example, the results presented for the 5% AEP event, 1% AEP event, and 0.2% AEP flood show incrementally how flooding can worsen at a location. In these examples, the formation of a flood runner is clearly shown to start first around a 1% AEP event before it develops into a significant flow path during a 0.2% AEP flood. As documented in the flood study, the results have been used to generate flood mapping for key outputs that include peak flood levels and extents, flood depths and flow velocities, flood hazards, and hydraulic categories, which includes the floodway corridor. Although flood peaks are typically presented in reporting, The results contain information for the full time series of a flood event. This gives valuable information to Council and the New South Wales SES about the rate of rise of floodwaters, the predicted warning times before roads may be overtopped, or the potential duration of isolation of an area. This example shows how the results can be viewed at various stages of a flood event. As discussed in the previous slides, a key component of the Hastings River Flood Study Extension project was the update and development of new modelling tools to allow flood information to be generated for a larger portion of the catchment. Further to this, through calibration to the 2013 and 2021 events, and by updating the hydrology to comply with the latest guidelines and data, the models were shown to be reliable tools that could be used for flood estimation. As expected, the range of updates led to changes in the predicted flood behaviour when compared to previous flood studies. Appendix F of the report presents a comparison between the latest results and those currently adopted by Council. As shown, the updated modelling predicts a reduction in flood levels upstream of Hibbard, combined with an increase downstream to the ocean outlet. Although perhaps an oversimplification of the reason for these changes, the reductions upstream of Hibbard are largely attributed to reductions in the peak magnitude of design flows, combined with the inclusion of the Maria River and Connection Creek floodplain, which acts to attenuate the rise of flood levels downstream in the Wilson and Hastings River floodplains. The increase in flood levels downstream of Hibbard is attributed to the model calibration, which found that the RMA2 model was under-predicting flood levels when compared to the recorded high water marks and recorded flood levels at river gauges. The model was adjusted accordingly, which resulted in a commensurate increase in flood levels for design events. The differences in peak flood levels between the probable maximum flood event and the currently adopted nominal extreme event is attributed almost entirely to the higher flows predicted for the PMF. As stated in earlier slides, flows for the PMF event are predicted to be 60% higher along the Hastings River and up to 35% higher along the Wilsons River.